If I asked you to think about household appliances that you use every day, what items come to mind? Now, do you understand scientifically how that particular appliance works? Well, in my case, my environment of choice was my kitchen, and when I answered the first question, the first thing that popped into my head was the microwave. So in this speech, I'll be giving you a brief history, at least a brief explanation of the history and physics behind the humble microwave, as well as some tips and techniques to improve the way your food comes out next time you use a microwave. Hopefully, by the end of my speech, you will have a deeper appreciation and understanding of the modern marvel that is the microwave oven. So to begin, I'm going to give you a brief history of the microwave. Microwave technology first came into use in the late 30s and early 40s in the development of radar. It was then used throughout World War II by the US government, but it wasn't until October 8th, 1945 that the first actual microwave oven was patented, used to actually heat food. So one of those prototypes was then sent to Boston to a restaurant for testing, but it wasn't until 2 years later, in 1947, that the first commercially available microwaves came out, and they were made by a company called Raytheon, and they were called the Radar Range. Now, this microwave was almost 6 feet tall, weighed 750 pounds, and cost a whopping $5,000. Now it would be $52,000 adjusted for inflation. So obviously not very many of the average consumers were purchasing microwaves at this time, but as the years went on, technology improved, the size of microwaves became smaller and smaller, and the prices began to fall and fall. By the 1970s, microwaves had already become a standard household appliance for most Americans. So now that I've told you a bit about the history of the microwave, I'm going to talk to you about how microwaves actually make our food hot. So according to Cosmos magazine, electrical energy is converted in the microwave by a small device called a magnetron into microwaves. So the magnetron then sends these microwaves into the oven cavity, where it bounces off the inner reflective surface and passes through the food that we're heating. So as these waves pass through the food that we're heating, the magnetism of the wave causes the dipolar water molecule to flip back and forth billions of times per second. And it is actually this movement which in turn creates friction and heat, which then heats our food from the inside. So for this reason, also, microwaves are very efficient. The other microwaves pass harmlessly through the microwave safe container that you're using, and the magnetron only has to expend energy on heating the food itself rather than the container containing the food as well. So with this knowledge, now we can understand and utilize several techniques to maximize our experience heating food with a microwave. First off, if you have the option, never put your food directly in the center of your plate. Microwaves tend to bounce around the edge of the plate and rarely go straight through the center. So mostly the food in the center is going to be getting heated less evenly than the food around the edges. Also, for that reason, place like thicker parts of your food toward the edge of the plate. Like if you're heating a drumstick, put it with the skinny part going towards the center, because less waves are going to hit this thinner part of the food and it's going to heat up more evenly. So thicker parts out toward the edge and thinner parts toward the center. Another good rule of thumb is you should probably always cover food that you're heating in the microwave, because not only does it prevent messes and splatters, it also traps steam within the thing you're covering it with, and also that allows for your food to keep from drying out and also heat up faster. I hope that, in conclusion, I hope that this speech gave you a more in-depth understanding of how a simple thing that we use around us works. I hope that it sparks some more interest into understanding the science and technology of the products we use around us every day. But most of all, I hope that this speech allows you to think about something next time you're watching your microwave popcorn get nuked.